Hello and welcome to Properties of Matter GCSE exam questions. So what's the little animation there? So this is exam questions, so taken from real GCSE exams. So sometimes the number doesn't line up with the number we got to because they're taken from different exams. Okay, so we'll get started on Properties of Matter. So in a hydrogen fuel cell, hydrogen and oxygen react at the electrodes. The overall reaction occurring in this fuel cell is a reaction of hydrogen and oxygen. Write the balanced equation for this reaction. So it's not just a word one, so let me just turn the pen on for here. So we've got hydrogen, and as it's a gas, it hangs around with another hydrogen, so it's diatomic. So does oxygen, so we've got O2. Goes to, and only water is produced, so H2O. So it says balanced. So let's see how many hydrogens we have. We have 2 hydrogens on this side. We have 2 hydrogens on this side. 2 oxygens, only 1. So let's try and put a 2 in front of this. So now we've got 4 hydrogens, 2 oxygens. So we put a 2 in front of that. The problem is solved here. So we've got 2 marks. The electrodes of a fuel cell are in contact with water and air. The electrodes are made of platinum rather than iron. State why iron is not a suitable metal for the electrodes of the cell. So iron will rust. So it will react with the water and oxygen. There's only 1 mark, but you go to not detailed there. Platinum acts as a catalyst. State in terms of its position on the periodic table why you would expect platinum to act as a catalyst. So catalysts are usually metals that speed up a reaction, and lots of catalysts are transition metals. So platinum is in platinum is in transition metals. Okay. Some metal objects are electroplated. State 2 reasons for electroplating a metal object. So it could be electroplated with a less reactive metal, to stop corrosion. So another reason would be for appearances. So to make the object more aesthetically, it's a weird word, isn't it? Aesthetically attractive. So e.g. electroplating gold on jewellery. Base metal jewellery. Okay. Many metals corrode. We just talked about that. When a metal corrodes, so it says the metal reacts with nitrogen. Nitrogen isn't very reactive. The metal reacts with another metal. Nope. The metal element decomposes. Doesn't completely decompose. It's oxidized. That's true. So yeah, you react with the oxygen in the air. An experiment is carried out to see if magnesium ribbon wrapped around a piece of iron rod has an effect on the rate at which the iron rusts. The apparatus is shown in figure 4. So I've got the iron rod and magnesium ribbon is wrapped around it. It's quite soft magnesium, you can wrap it around it. So just an iron rod on its own. So this is, yeah, they were getting ideas like a sacrificial metal from this. The method used is an iron rod with magnesium ribbon wrapped around it is placed in a boiling tube labelled A. 10 centimetre cubed of water from a measuring cylinder is poured into this boiling tube. An identical rod with no magnesium ribbon wrapped around it is placed in a second boiling tube labelled B. 10 centimetre cubed of water from a measuring cylinder is poured into this boiling tube. Both boiling tubes are left for a few days. Explain why the iron rod rather than stainless steel is used in this experiment. So the stainless steel is that used to make cutlery and things like that. So stainless steel does not corrode. That's what it's called, stainless steel. Stainless steel does not corrode, so no difference would be seen. So, whereas iron rusts, so rust is only used for iron. It's another word for corrode for iron. It's only used for iron. Iron rusts, so a difference could be seen. Okay. Titanium 4 oxide is an ionic solid. Many ionic solids are soluble in water. Titanium 4 oxide is not soluble in water. Okay. Its other physical properties are typical of ionic solids. Predict one other physical property of titanium 4 oxide that would be typical of ionic solids. So other ones would be like a high melting or boiling point. So we go for high boiling point. The formula of titanium 4 oxide is TiO2. Deduce the charge of titanium ion in titanium 4 oxide. Well, there's two reasons. It's called titanium 4 because it's a +4. Okay, I'll give you a clue there. That's actually what the reason for that number is there. Roman numeral is. But we're probably asked to think about oxygen. There's two reasons for this. So oxygen forms a 2- ion. So we know, okay, if there's two of them, it's got a +4. But also, that there is a +4. That actually tells you it's a transition metal. If they've got a number after it, it means what ion it forms. Fluorine, chlorine, bromine, iodine, and astatine are elements in group 7. Describe the test to show that a gas is chlorine. Okay, so chlorine is actually an acidic gas. Okay, it's an unusual one. So chlorine is an acidic gas. So placing blue litmus paper into a test tube or boiling tube of chlorine gas would cause the litmus paper to change from blue to red and then bleach to white. Chlorine bleaches things, quite a dangerous chemical. Bromine reacts with hydrogen to form hydrogen bromide. Hydrogen bromide dissolves in water to form a solution. State the name of the solution formed. Okay, so it's actually just called bromine water. Okay. There is a trend in the colour and state of the halogens at room temperature. Predict the colour and state of astatine at room temperature. Right, so let's think about it. We've got fluorine. So they're in a group 7. Okay, so I'm going to get onto the compounds in a minute. So chlorine, and then we've got bromine, and then we've got astatine. Astatine is actually the rarest element on Earth, so I'd like to come across it. Right, so this is a gas. This is a gas. Oh, we've missed out iodine. Iodine's here. Bromine's sort of liquid gas sort of thing. So yeah, it gets more solid. Iodine's a solid. So astatine, we're going to predict as a solid. They get darker as this. This is kind of a yellow. This is green. This is brown. That's kind of a purple. So getting darker. So I guess black. Okay. Bromine, chlorine, and iodine are dissolved in water to make aqueous solutions. Potassium iodide solution is added to each of these solutions. Figure 6 shows the observations. So we've got halogen, bromine, initial colour of aqueous solution orange, final mixture brown. So halogen, chlorine, pale green, yeah, it's a green. Iodine crystals can be purple, but they've got a brown purple. So pale green, final mixture brown, iodine brown, final colour brown. So let's have a look what potassium iodide is added to each of the solutions. So let's have a think. So got bromine, chlorine, iodine dissolved from aqueous potassium iodide solution added to each of these solutions. Okay, so explain the observations. So let's just write this out a bit more carefully. It's 4 marks. Let's be a bit more careful with this one. So let's think about the first one. So bromine solution changed from orange to brown when potassium iodide solution was added. So think about what's going on here. So bromine solution changed from orange to brown when potassium iodide solution was added. So a reaction occurred. Okay, so chlorine solution changed from pale green to brown when potassium iodide, yeah, I forgot what it was, potassium iodide was added. A reaction occurred. But however, when potassium iodide was added to iodine solution, no reaction occurred. Okay, So let's think about why this was. So what's happening here is a potassium is reacting with the chlorine and bromine to form potassium bromide and potassium chloride, and displacing the iodine. As bromine and chlorine are more reactive than iodine. Okay. So fluorine reacts vigorously with iron to produce iron-free fluoride FeF3. Write the balanced equation for this reaction. So fluorine, the gas F2, plus Fe, 2F's there, goes to, and we're told FeF3. Okay, so got 3 fluorines on this side, 2 on that. So we could try 3 and a 2. That might work. Okay, so 2, we've got 6, 6. Now we need a 2 in front of that. Okay, and that's done. Sometimes it's just trial and error, really. A sample of potassium carbonate is contaminated with a small amount of sodium carbonate. So potassium carbonate, sodium carbonate. When a flame test is carried out, a bright yellow flame is seen. Describe how you could show that potassium and sodium ions are present in this sample. The flame test of bright yellow flames, potassium and iodine. So we could have got potassium, sodium carbonate. So we could have so sample of potassium carbonate contaminate a small amount of sodium carbonate. So sodium carbonate is showing the bright yellow flame. So potassium and sodium. So we could have a precipitation reaction here. So if you look at what we had before about things reacting, so the sodium carbonate could be dissolved, and so the carbonate, so we're assuming there the carbonate could be dissolved, and sodium, so and potassium, so it will react to potassium iodide could be added to displace the sodium ions and produce a precipitate. The yellow flame is already indicating sodium ions. Sodium ions produce a yellow flame. Okay. Hydrochloric acid reacts with a solution of sodium carbonate. 2HCl aqueous goes to 2Na2CO3, 2NaCl plus 2CO2H2O. Write the ionic equation for this reaction. Okay, so we've got HCl. So HCl forms minus, that's sodium carbonate. So NaCO3, so it's a carbonate ion. Okay, so we've got two. So if you think about it, we can kind of work this out, can't we? So minus, so that must be 2 plus here, carbonate of 2 plus, goes to 2 NaCl plus minus plus CO2, that's plus H2O. Okay, so thank you for listening, and good luck with your exams, and hope to see you in another video. Thank you, goodbye.